Hey guys, in this video we're going to learn how to execute shell commands using Python. By shell commands I mean the commands you normally run on your terminal or the command prompt. Many a times there are situations where the only option for a Python program to interact with some other program is through their CLI or the command line interface. So in that case we need to know how to execute the CLI or the shell commands using Python. Earlier, there was only OS module to do this task, but as Python evolved, it got a much powerful library called SubProcess to do this job. In this video, I will first of all give a brief overview of the OS module's functions for running shell commands and then fully explore the SubProcess module with a lot of interesting examples. So without any delay, let's get started. Okay, so before we take a look at any of the functions provided by Python for executing the shell commands, let us try to understand what exactly happens when we say that we are trying to execute a particular shell command. So your Python program is basically running as a process, right? So let us call it P1. So now when we say that we want to execute a shell command, what we actually need is a command line interpreter. So every operating system has a command line interpreter, and in order to invoke that command line interpreter and tell it to execute your given shell command, what you need is another process, because both command line interpreter and your Python program cannot run in the same process. So what happens is that your Python program's process will invoke a new process, a child process, or you can call it a sub process. So that, let's call it P2. So that is now responsible for running the command line interpreter and executing your shell command. And what happens is that now your parent process P1 can wait for P2 to complete that thing and try to get the status code of whatever the result of the execution of that shell command was, or any particular result which was produced, any output which was produced on executing that particular shell command. So in this way some communication happens between both the processes, and in a way you are just calling a particular function in Python, but behind the scenes a process got created, and that process ran something, and that process communicated with your Python program to provide it back the required output. Now let us have a brief overview of some old methods used for executing the shell commands using Python. So all these functions belong to the OS module and were being used for a long time until SubProcess module was introduced as a better alternative. Although you won't be using these functions in your code anymore, but still, these functions are pretty simple and can increase our understanding of shell command execution. That's why we're gonna quickly go through them. So let me just first of all import the OS module, and the first command or the first function that we're gonna check out is the os.system. So os.system will take the command as input, and let us see what it returns. So look at that, it is returning me 0 for running the ls command. So ls command in Unix or Unix like system will simply return the list of files and directories in your current working directory. So I am getting 0, not the actual output, which should have been something like this. So that is because on Unix systems the return value is the exit status of the process, and 0 value of the exit status means that everything went fine, there were no errors. But if you get something else, for example if I run os.system and let me just try to run rmxyz, which is meaning that I'm trying to delete something which actually doesn't exist, because as you can see there is nothing called xyz on my current path. So if I just try to run it, I'm getting 256, and it simply means that something bad happened and the command didn't run successfully. So that is what is the exit status. And in case of Windows, actually you will not get the exit status, instead you will get the actual output of your shell command execution. So that is a bit of different behavior in different kind of operating systems for this particular function. And now coming to Unix users, as you can see that for the Unix users there is clearly a limitation here for using the os.system command or the function, that you cannot get the output, right? So in order to get the output of your shell command execution, what you can use is the os.popen function. So os.popen function will again take your command as the input, and actually it returns you an open file object. So you can simply do the read over that open file object, and you will get the output. So look at that. We are getting the output, which is the actual result, which should be the actual result of my command. So let me just do a print to show it in a better way. So look at that. It's correct, right? It is just the same thing which was being returned by the normal command execution. So in this way, you can use the popen. And lastly, we have something called os.spawn. Actually, this function has multiple names with some different variations, and that is because of the type of arguments that can be passed to it. But the main thing that you need to understand about it is that it executes the program path that you pass in a new process, and the name actually suggests the same, that os.spawn means that it is gonna start a new process for executing the program whose path you are gonna provide. And the first argument is mode, which is gonna have two values. You can provide any of those two values, which is p_no_wait or p_wait. So if you say p_no_wait, what will happen is that this function will not wait for the completion of your command execution. It will simply return the ID of the process which is running that command, and that's it. You will get that output and that's over. But in case of p_wait, it will wait for the command to execute completely, and if the execution was done normally, then it will simply return the exit code. But if you try to kill the process, then it will return the signal which was used for killing that process. So let us just have a very quick example of os.spawn as well. So os.spawn, let us go with the simplest one, spawn L, and now the mode. So we are going to go with the no wait mode so that we can see the process ID. And now I have to provide the path of my program. So here I have to provide the path of the command line interpreter. So generally in Unix systems, the path to the command line interpreter is /usr/sh, and then my actual command, which is ls, and that's it. Look at that. I'm getting the process ID as the output, and if I keep running it, I will keep getting different process IDs. So yeah, so in this way os.spawnl works. It simply spawns a new process and just returns you the process ID. Okay, so finally we're going to talk about the SubProcess module. So the SubProcess module provides more powerful ways to manage and communicate with the subprocesses which are responsible for executing our shell commands. So the main API of the SubProcess module is that it has a function called run and a class called popen. So the run function is responsible for running any shell command, and it will wait for it to complete, and then it will return something called a complete process class object. So complete process instance is what you get as the output of this particular function. An interesting thing about the run function is that it was added only in Python 3.5. So before Python 3.5, what you had was multiple functions to do the same thing which run can do on its own. So there you had something called a call function, then a check call function, check output function, and all those. But all these things can be done using a single run function now because of the number of arguments that it takes. So in a way, run is a quite versatile function for running shell commands. And if you are thinking of using any of these functions, then you should try to refrain from using them because they are now a part of the older API which should not be used. Although they are still supported, but you should not use them. And yeah, so the thing is that we have the run function, and then we have the popen class. So the popen class is a class for flexibly executing a command in a new process. So basically run function internally is basically using the popen class for doing any kind of execution of your shell commands. Interestingly, the OS module's popen function also uses the subprocess.popen class for executing the shell commands. So now let us, without any delay, let us start with the run function and try to see what all it can do, right? So let me start by first of all importing the SubProcess module, and let us try to look at the signature of the subprocess.run function. So the first argument is called popenargs, and then we have some other parameters there. So the first thing is popenargs, which can either be a string or a list of strings. When it is a string, then it should be the name of a program, and when it is a list of strings, then you can provide the arguments that you want to add with that program. So let me show you that with an example. So let's say my command is ls. So let me just run it. So look at that, I'm getting an instance of completed process class, and the return code is 0, which means that my process exited with the status code 0, which means that everything went fine. And you can see that I'm not getting the output, and we will look into it in a bit. But before that, let us just look at some other command, which is, let's say, python 3 test.py. Let's say I want to run this command. So in my current location, I have something called test.py, so this should run, right? So let me just run it, and look at that, I'm getting file not found error. Why? Because it is thinking that python 3 space test.py is the name of my program, but actually the name of my program is python 3 and test.py is just an argument. So for these kind of cases, what you should do is you should pass a list of string like this, python 3 and then test.py, right? So in this way it will run, right? And yeah, so this is how you can run commands by providing a string or a list of strings. And now let us try to see how do we get the output, how do we read the output from the execution of our shell command. So before python 3.7, so let's say you have python 3.6 or 3.5 or less, then what should you do in order to read the output of your shell command? So for that you will do subprocess.run. Let's say our command is still ls, and then you have to do standard output stdout. This is the name of a parameter where you have to pass subprocess.pipe as the value. So what will happen is that subprocess.pipe opens a pipe to the standard stream, which simply means that whatever output is being produced by that particular process, that will be available to your program and will be available to you. So if I just try to run this, look at that, we are getting one more value here, which is called stdout, which is containing the result of my shell command execution. So if I just try to read it, let me just do something like this, result equal to this. So result dot stdout, and I'm getting this, and this is a byte string, so I will have to decode it to convert it to a string, and then I can simply print it to get it in a pretty format. So in this way we can read the output of our shell command execution. So this is how it works. And now let's say there was some error while executing something. For example, let me just try to run a command rm xyz. So it is trying to remove something called xyz from my current working directory, but there is nothing called xyz here, right? So it should just throw an error. So in that case, let me just try to run this. And okay, so now one thing that you can notice here is that we are getting file not found error, because I should not have passed it like this. I should have passed it like this. Okay, so we are getting some result. So let me just put it like this. So we are getting the result, and the return code is not 0, it is 1. And the return code 1 means that some error happened, something bad happened, and that's why the standard output is nothing. But what is the error? I want to know the error as well, right? So if you want to know the error as well, then you should do stderr is equal to subprocess.pipe. So that is the same thing again. You are trying to stream the information from other process, the process which is running the command for you, to your Python program. And look at that, we are getting the standard error, which is that it cannot remove xyz because there is no such file or directory, which is fine. So in this way we can read. And now one more feature that we have here is that, let's say you do not want to have two different fields for getting the output from the shell command execution. Let's say you want to get this information directly in your stdout value only. So for that, what you can do is that you can replace pipe with stdout for your standard error value, and then you will get that in the standard output only, not in the standard error. So this is something that you can do in order to make it a bit more uniform in a way. So yeah, so this is how the things are working for reading the output. And if you are a Python 3.7 or 3.8 user, then there is some good news for you, that there is something called capture output parameter which was added after Python in Python 3.7. And let us try to see how it works. So subprocess.run ls, and then instead of writing anything like standard output equal to pipe or standard error equal to pipe, you can simply do capture output equal to true, and that's all that you need to do, and you will get the output. So we are getting the standard output, which is the correct value, right? So what happens is that putting capture output equal to true means that you are setting the standard output as pipe and standard error as pipe, and that will happen automatically for you. So that is this, but still this has simple limitation, which is that you cannot get this functionality, which is putting standard output as pipe and standard error as standard output. So that is what you will not get if you are using capture output. So yeah, so this was how simple reading the output for your shell command execution can be if you are using the SubProcess module. And now let me move to a very interesting thing here, which is running commands by passing single string. So just to remind you, a few minutes earlier we did subprocess ls-a, let's say. So we are getting file not found error, or we are doing python3 test.py, we are getting this error, right? But what if you like to put your commands in such a way, because that is the natural way of writing shell commands, right? So what you can do is that you can do shell equal to true. So in that case, it will not treat as the name of a Python program, name of a program which needs to be executed through your shell, but this will be treated as the complete command. And now if I run it, I'm getting the output, which is fine, right? So in this way, we can use the shell parameter in order to change the behavior for looking at the args parameter. So this is the thing, but there are some security considerations if you're using shell equal to true. And trust me, those considerations are actually serious. So let me just give you an example, okay? So let's say you wrote an application in which you are taking some input from the user. Let's say the user provided the input as a.txt. This input can be anything. And then you are generating a command which is, let's say, a cat command. Cat command can simply read something for you. For example, cat a.txt. I can get the content from a.txt, right? So this is the command, and then you want to do subprocess.run the command, and let's say the shell equal to true because you want it to happen, and let's say the capture output equal to true as well. So if I run it, look at that, everything seems fine. I'm getting the correct value ABC, new line DEF, which is fine. But now let's say the user is thinking of doing some really bad things with your system, and what they do is that they do some shell injection. So what happens in shell injection is that the user provides some input which contains some shell code. So when you're trying to put that input into your shell command, then you are executing that their provided malicious shell command as well. So let me just give you an example. Let's say they put something like this, a semicolon, and then they do pwd. Pwd will return the present working directory. So now what happens is that they will get something extra, which is the present working directory as well. And there is no limit up to how harmful this command can be. The hacker can do rm-rf asterisk, and this will simply delete everything which is present in your current directory. So this is just not acceptable for any kind of Python program, right? So what you need is some foolproof way of using the shell equal to true parameter, right? So for that, what we can do is that we can use something called shlex. So shlex is another built-in Python module which can quote the argument for you, which can quote some parts of your shell command in such a way that if it contains some if inside it contains some more shell commands, then those are escaped. So let me just give you an example here. So let me just do shlex dot quote, and let me just quote the user input. So look at that, it has quoted the complete thing, and if the user input is a.txt, let us see what happens. Look at that. If the user input is a.txt, then shlex finds no problem with this particular input because this looks fine. But if your input contains any character which has some special meaning for the command line interpreter, then what it will do is that it will quote your complete string. And in this way, what will happen is that you can see for yourself that, so first of all, let me do it like this. Command equal to, so let me just copy this and make it a bit more simpler. Command equal to, and there we use schlex dot quote and putting the user input. So this is my command now. The command is this. So now you can think that what this command is going to do. This is going to treat this complete thing as the first argument, and in this way the shell injection will not work and you will get some kind of error here because there is nothing called a.txt space semicolon pwd. So if I run this, look at that, the hacker will actually get the error that this cat command didn't work, right? So in this way we can make our program a bit more secure and prevent it from shell injections if we use schlex for quoting the parts of our shell command. So whenever you're using shell equal to true, then just try to quote your command with schlex.quote. So this is the thing. And one more thing before we move ahead to the next topic, and that is that it is always better to use the list of strings instead of putting the strings like this, instead of putting your command like this. So what if you want to just generate that particular list of strings? So for example, in this case it will be cat a.txt and pwd. Let's say this is my command, right? So actually schlex provides you schlex.split, in which you can pass this, and what it will return is the list of arguments that you can simply pass to subprocess.run for execution. Now the interesting thing about it is that, let's say your command was something like cat and then you had abcdef to, let's say you want to save some string to a file called a.txt, right? So what does this command do? It will simply write abc space def to a.txt. So schlex.split is smart enough to break it down in such a way that it will not break down the space between abc and def because it knows that it is a quoted string and it is actually acting like an argument. So that's why it will put it like this. So in this way it is a bit smart, schlex.split, and you can use it whenever you want to prepare the list of strings. So yeah, so that's it. So that is how you can do the run command by passing single string. So this was the thing about it, and it is always better to pass a list of strings. Now coming to run command and pass input. Okay, so let us try to look into how can I pass input to my program. So there are sometimes some programs that you want to run through shell command execution which take input during their execution. So for example, let's say a Python program. So I have a Python program in my current directory test.py. So let me just show you how it looks like. So this program takes two inputs and then it just prints their values, right? So now this program needs input during the execution. So what do you do in that case? So for that particular case, what you will have to do is you have two options. You have the input param or the standard input param. So let me just start by the input param. So subprocess.run, and my command is gonna be python3 test.py and shell equal to true, because why not? Although I'm still advocating that I should not be using shell equal to true. So let me just keep it like python3 test.py. This looks much better. And then let me just try to go with the capture output equal to true because I want to see the output. And now input. So what should be the input? So the input that you have to pass should be a byte string, right? So how do I pass a byte string? So what should be my input? First of all, my input should be, for value of a I want to pass abc, let's say, and for the value of b I want to pass def. So I'm just putting a new line so that Python interpreter understands that now I'm moving to the next input. So ABC, DEF, those are the two values that I want to pass. And in order to convert it to a byte string, I will use encode, and it looks fine. So look at that, I ran it and I'm getting the output as you said ABC and DEF, which is the correct output of my shell command execution. So in this way we can pass input to our shell commands. And now to make it a bit more simpler, let's say you do not want to encode it, then what you can do is that you can do universal new lines equal to true. So this is another parameter that you can pass, and that will now make input accept strings as well. So as you can see, we are getting the output again. And universal new lines actually has an alias since Python 3.7, and you can simply pass text equal to true, and that will also work. So text is a much better name for saying that you are going to accept the strings. So that's why that is working, and that will work, and that has been there since Python 3.7. And yeah, so these are a few ways of passing the input if you know the actual string. But what if you want to pass the input directly from a file? For example, let's say I have a.txt in this way. So this contains the same input that I have as a string here, but I want to pass it directly through my file. So in that case, you will use the standard input parameter. So let me just copy it here and replace input with standard input. So stdin, and now I have to pass a file reader. So I have to pass a file object. So I will just open a.txt here and open it in read mode, and that's all I need to do. And look at that, again the same output, you said ABC and DF. So in this way we can see that we are able to pass the input from a file as well. So these are a few ways of passing the input while running our shell commands. And now only two things are remaining, so let us wrap them fast. So we have something called a timeout parameter as well. So in order to understand that, let me give an example. For example, let's say there are some commands which take a lot of time to run, and you want a hard limit on how much time you want to spend while running that particular command. So in that case, you can set a timeout value for that particular command. And in order to show how it works, let me just use the sleep command. So let me use sleep 5. So this is my command. It will simply make my command line interpreter sleep for 5 seconds basically. So this is the command, and let me just put timeout equal to 3. So what will happen is that it is surely gonna time out, right? So this will time out. I will get the error as the timeout expired, and that is correct. And just to be sure, let me just do once more with sleep of 3 but timeout of 5, and we are good to go. So it looks cool. And finally, let me just try to go to the last thing, which is, let's say you want to run a command and you want to throw an error if you fail. For example, we have subprocess.run ls, or let's say rmxyz, right? So rmxyz, and then what happens if I run this command? I get return code as 1. But let's say I want to actually throw an error if any failure occurs while executing my shell command. So in that case, what you can do is that you can simply pass one more parameter, which is check equal to true. Check equal to true, and what it will do is that it will throw the called process error if any error happens while executing your shell command. So if my command had been successful, then it's fine, but if it is not successful, then it will throw that error. And what you can do is that in order to handle that error, you can simply do try, and then you can do except subprocess dot called process error. So if this particular error is happening, then what you want to do, let's say you just want to print that failed, so you will get the failed. So in this way we can run commands and throw errors if fail, and then we can catch those exceptions and do anything with it. So yeah, so this was kind of long video and we learned a lot of things, and I will be sharing this complete Jupyter notebook with you so that you can use it as a refresher whenever you want to learn about executing shell commands using Python. And if you still have any doubts, you can put them in the comment section below. That's it from this video. Thanks for watching.